Okay, as we just talk about now, like given is knowing B is happen or given B is happen. And why the probability will change? Just look at this Venn diagram. Okay, look at this Venn diagram. The notation of probability A is whatever in this circle, okay, here. The elements in this circle divide by this area. Because you don't know anything yet, that was purely the probability that from that circle divide by the whole area. Okay, that's the probability A. Okay, things in A divide by total. But when we talk about probability A given B, you know B is happening. Okay, B is there already. You want to know A can occur at the same time. Okay, A could occur at the same time. If we think about this area here, this area means only A. B is not happening at all. So it can't be this part of the elements. So the only part of elements satisfy that B happened already and I want A happen as well is the intersection part. Okay, it's this intersection part. Because B happened already, so I want A also happens. So this is the intersection part. So because you're talking about, like, you restrict your total elements, so you restrict your total set into the B. So it's this red part divided by this green part. Because that become your whole set, universal set now. Because B happened already, so that is reduced, the rectangle reduced to that circle. And then I want B happen, A also happen is the intersection part. And divide by universal set, which is B in this case. So the probability A given B will be calculated by A intersects B divided by probability B. That's why we can see that on the Venn diagram. And if we say B given A, okay, what is at the back is what you already know. Okay, you already know, it's already happened. So this time is A already happened. Okay, A already happened. So your total universal set reduced to A. Okay, reduced to A circle. So what you need to divide is probability A this time. And then again, A happened already and I want B happen at the same time. So it's A intersects B as well. Okay, still the intersection part, but the total become probability A. Okay, so that's the two formula. And what we learn now is equal likely events. Okay, year 10 we learn equal likely events. So if it's equal likely events, we can further analysis this. Okay, so we have probability A intersects B divided by probability B. So what is probability A intersects B? Is the number of elements in A intersects B divided by the number of elements in the total set. Okay, so that is the probability of A intersects B. What is probability B? Probability B is the elements in set B and divide by the total number of elements in the whole set. If we times number of total on both top and bottom, okay, we times number of total on both top and bottom, we can reduce that into number of in A intersects B divided by number of B. So this only true when is equal likely events. This only true when it's equal likely events. In year 11, year 12, you will still use the formula, but only the front part, okay, not the back part. Because as I said, not all the events will be equal likely. And not all the events will be countable. What we learn now is called discrete probability. Everything is countable. Okay, we can count 1, 2, 3, 4 elements. Later in year 11, year 12, you will learn continuous. So it's countless. Okay, you can't talk about the number of elements in that set. It's a countless number of things in that set. So we can't use this formula anymore when you go year 12. So remember the blue square here is only work for equal likely events. Okay, equal likely events. But the red circle is always true. Okay, the red circle is always true. And same thing here. Probability B given A is A intersects B divided by probability A. So number of A intersects B divided by number of A. Again, this only works for equal likely events. Okay, only this part, this works for equal likely events. Okay, have a think about the two examples below. Okay, example 1 says, in Stephen's class, 12 students study Chinese, 12 study French, and 8 study both Chinese and French. Can you draw me a Venn diagram to show this situation, please? Okay, draw a Venn diagram. You don't know the total, okay? You don't know the total, but it's okay. Just do not worry about the total. Do not worry about the A dash intersects B dash part. Okay, just purely show the 3 elements in the circle. You should have something like that, but I don't know the x. Okay, the x is the A dash intersects B dash because I don't know how many students are there in one class. Well, if we assume that's 25, it will be 1 outside. Okay, if you assume 25, then it will be 1 outside, but like, it's okay. So this question shows you that, well, think about what I want. The first question says, given a student in the class, his class study Chinese already. Okay, study Chinese already, given Chinese. So Chinese will be after the given, the bar, okay, after that. And what is the probability they also study French? So A is the probability of studying French given studying Chinese. Okay, the notation will look like that. I'm asking French, so French will be in the front. Telling you that study Chinese already, so given Chinese. So if you use the first formula, it's probability French intersects Chinese divided by the probability of Chinese. If I purely use this formula, I can't do it. Why I can't do it? Because I don't know the total. I can't find probability of Chinese. Okay, probability of Chinese should be done by 12 divided by the total number, but I don't know the total number. So this time, I must use the number of French intersect Chinese over the number of Chinese here. Okay, using this formula, we avoid total. Okay, we avoid total. So I don't care what is the total. It will get cancelled from both top and bottom. Okay, if you assume 25, that will be the same. Assume 35, that will be the same. You get cancelled from top and bottom. So the number of, okay, so it's given you Chinese, so there's only 12 students eligible, okay, when we talk about this case. So 12 reduced to the Chinese circle, 12. And then I want to know the intersection, which is 8. So this is 8 on 12. Okay, 8 on 12. That's 2/3. Okay, 2/3. Okay. B, like the reverse way, given that a student in his class studies French, what is the probability that also study Chinese? Okay, the probability of Chinese given French this time. Okay, you know already study French, then 20 people eligible when we talk about this case. Okay, 20, only in the French circle. Then it will be the probability of Chinese intersects French divided by the probability of French. Then you will have number of Chinese intersects French over the number of French. Intersection will always be 8, but French will be 20 here. 2 on 5. Okay, 2/5. 2 on 5. Okay, have a think about example 2. Okay, have a think about example 2. Give you 2 minutes to do the first two first. Okay, represent the information in two-way table and find the probability only set on the bench. Okay, so set up the two-way table or the probability table or assess the Kano map. Okay, I think most of you finished that. Let's have a look. A group of 15 players, okay, 13 on the field, 7 sat on the bench, and 5 both played and sat on the bench. Okay, so let's just do. Okay, I'm not using rulers. It should be a 4 times 4 table. Okay, let's use, okay, let A be the event the person play on the field. Okay, have A and A dash. B be the event set on the bench, B and B dash. There's 15 people in total. Okay, 13 play on field. Okay, 13 here. 7 set on bench. 7 here. 5 play both play and set on the bench. 5 will be here. Intersections. Right? That's the 4 informations you can write. 4 information you can write. And if I go to do that, that will be a 2. That will be an 8. That will be a 2. That will be a 0. And that will be an 8. Okay, add horizontally. 2 plus 5, 7, 8 plus 0, 8, 13 plus 2, 15, vertically 5, 8, 13, 2, 0, 2, 7, 8, and 15. The 0 here, which makes sense, because you won't have anyone not play or not set on the bench, and why you be in the team, so that will be 0. So which means we have a correct table here. So that's A. So B talks about find the probability that the person only sat on bench. Okay, probability. Okay, only sat on bench is B. B only. Okay, B intersects A dash or A dash intersects B. Doesn't matter. So that's how you use the notation to do that. In this year, you can. That's not a big problem. why I want to do this is because in year 11, year 12, when the question gives you something, the question can be, especially year 12, the question can be very complex. And the only way to reduce the complexity is you can give a notation. Because when you write out the notation, you know which formula you can apply to it. It's much easier to see by a notation other than words. It's just make your life easier later. So in this case, it's okay because you know it's very simple, only like one sentence, so you know what you're talking about. But later, when you give mathematical representations, a lot of things like before, I'm not quite sure what I should do, but after I give the formula out, okay, I see that's a given probability. Everything just follow the formula. It's very easy to deal with. Okay, so especially the given case, if you write that in the given notation, then it's very easy to do later. So B intersects A dash. B intersects A dash. That's 2. Okay, that's 2. That's 2 over 15. Yeah, 2 over 15. I see some of you put that into decimals. Okay, do not put that into decimals because it's not a divisible number. It's not like 0.3 or something. So do not do that. Okay, you have infinite many decimals and you can't represent in the exact way unless the question asks you to do so. C. Find the probability that the person sat on the bench. Okay. What you need to write is when you read it, you can directly change into the notation. Find the probability that the person sat on the bench. So that must be a B. The probability of B. Okay. Given that, so you have a bar here. They play on the field. Okay, you already know that event A happened. Okay, you already know event A happened. So that equals to number of A intersects B. I just skip the middle step. And that's the number of A. Okay, the number of A intersects B divided by the number of A. So A intersects B is a 5. The number of A is a 13. Okay, 5 on 13. Okay, 5 on 13. Again, do not, okay, do not put that into decimals. You can't put that into exact decimal, so do not do that. Okay, 5/13. As I mentioned, like, you need to really pay attention start now, because year 11, year 12, that can be a very important case. Exact values, okay, exact values. Unless the question says how many decimals, you can see the word how many decimals in your question. Otherwise, do not change it. Why you want to waste 1 second to put in your calculator and then find decimals and copy a decimal? Just leave it as an exact form. Okay, that's easy for you and easy for us to mark, and you're not losing the mark. Okay. That's C. Okay, D. Find the probability that the person played on the field. So the probability played on the field, given that the set on the bench. Given set on the bench. Okay. So that's number of A intersects B again. Divide by the number of B. Okay, divide by the number of B. Intersection still 5. And B is 7. Okay, so 5 on 7. So 3 also needs to be in fraction form. Okay, 3 also needs to be in fraction form. Okay, that's conditional probability. So conditional probability is reduce the big universal set into one event. Okay, reduce the total now by knowing some information, and then find the intersection part and divide by the reduced universal set. Okay, so that's the whole idea of that. Okay, I will just stop here today. Tuesday we'll start exercise E then.